Hi everyone, my name is Shanti Devi Danasegaran. Here today I am going to explain the topic about energy density in electrostatic force. What is energy density? Energy density is the amount of energy stored in a given system or region of space per unit volume. So here, let's relook the concept of the energy density. Here I have the empty space of the system with three charges Q1, Q2 and Q3. So first, when we move the Q1 to point P1, we get the work done is equal to 0. Why? Because there are no other charges presenting in that system. So next, when we move Q2 to point P2 from infinity, the work done for Q2 is equals to Q2 V21, where V21 is the potential due to charge Q1. So next, when we move the Q3 to P3, the work done Q3 is equals to Q3 in bracket V31 plus V32, where V32 and V31 is potential due to charge 2 and charge 1. So hence, the total work done in position 3 charges is equals to W1 plus W2 plus W3, where W1 is equals to 0 and W2 is equals to Q2 V21 and W3 is equals to Q3 V31 plus V32. So we let this equation as a first equation. Okay, next, if the charges were positioned in the reverse order, W is equals to W3 plus W2 plus W1, where the work done for charges 3 is equals to 0 and the work done for Q2 is equals to Q2 V23 and the work done for Q1 is equals to Q1 in bracket V12 plus V13. So we let that equation as 2. By adding equation number 1 and 2, we will get 2W equals to Q1 V1 plus Q2 V2 plus Q3 V3, where V1, V2 and V3 are total potentials at P1, P2 and P3 respectively. We also can write the summation for this equation, which W is equals to 1 over 2 summation K equals to 1 and Qk Vk. When K equals to 1, it will get Q1 V1. According to the Gauss's law, rho V is equals to nabla dot D, where we substitute that into the equation. So it will get W equals to 1 over 2 integral nabla dot D V. After that, we use divergence theorem to derive this equation. From that, we can define electrostatic energy density is equals to 1 over 2 epsilon naught E squared equals to V squared over 2 epsilon naught. So next, let's look from solve problem part. So here, I have example from practice exercise 4.14, which the question asks point charges Q1 equals to 1 nanocoulomb, Q2 equals to negative 2 nanocoulomb, Q3 equals to 3 nanocoulomb, and Q4 equals to negative 4 nanocoulomb are positioned one at a time and in that order at 0, 0, 0, 1, 0, 0, 0, 0, negative 1 and 0, 0, 1 respectively. Calculate the energy in the system after each charge is positioned. So here I have drawn the system with the 4 charges with its position. So the question asks us to find the work done for each charges. So first we find the charges for Q1. As we know, the work done for Q1 is equals to 0. Why? Because there are no other charges presenting in that system before it. So next, we find for work done Q2. So, equation for work done for Q2 is equals to Q2 V21 plus work done 1. So as we know work done 1 is 0, so we simply find the V21, which is Q2 Q1 over 4 pi epsilon naught magnitude, the position which is 1, 0, 0 minus 0, 0, 0. So we will get negative 18 nanojoule. So next, we have to find work done 3 for charge 3. So the equation is work done 3 is equals to Q3 in bracket V31 plus V32 plus Q21 V21. So Q21 V21 is actually the work done 2. So as we know, in the system we have the work done Q2 and Q1. So we have to consider the work done for Q2 and also Q1. So as usual, we just simply insert the value and we will get the answer is negative 29.18 nanojoule. Okay, finally we have to find work done for Q4. So the equation will be work done for is equals to Q4 in bracket V41 plus V42 plus V43 plus Q3 in bracket V31 plus V32 plus Q2 V21. As we know, for work done for charge 4, we have to consider the work done for Q3, Q2 and also Q1. So as simple, we have to insert the value and the answer is negative 68.27 nanojoule. So finally, that's all my explanation about the energy density in electrostatic force. So special thanks to Dr. Nurisha because give me this opportunity. Thank you.